All right, here's one. Negative 1, positive 1, negative 1, positive 1. Which is known as, okay, kind of like oscillating back and forth, isn't it? Yeah. All right, now, conversion or diversion? It never really takes off, but it doesn't converge. As long as it doesn't converge, it's diversion, right? Okay? And the next term would be what? I go right back to negative 1 again. Okay? But what about the formula to generate all these numbers? So when I put in 1, I get negative 1. 2, I get 1. 3, I get negative 1. 4, I get positive 1. That's clever. Let's see. You notice when you get negative 1s? Right? Yeah. When you put in an odd, you get negative 1. But when you put in an even, you get positive 1. So how do I make a formula that every time I plug in an odd, I get negative 1, and every time I plug in an even, I get positive 1? Negative 1
Did you just talk?
to the end.
What was the question?
That was worth talking for.
Oh.
Very few people ever get that right in 15 years of me teaching. That was quick. That should be a plus 50. But by the rules, I have to only give a plus 10.
Monumental. What did he even say?
I didn't, yeah.
The plus 10 board is just off the screen here, actually.
We didn't even hear what he said.
Negative 1 to the nth power. So weird. All right? Guess what? If you take negative 1 to an even, wouldn't that become positive 1? But negative 1 to an odd power would stay negative 1, right? All right? You will see this in college as well. What was that?
I said Jared Shulman got that one last year.
I think you did, actually. I mean, Steve Shulman? I would guess that he probably, yeah, I think he did, actually. So, anytime in this class, calculus, college, you're going to have sequences that you're trying to make oscillate back and forth. If you want a sequence to oscillate back and forth, use negative 1 to the end. It'll change the sign for you every time. Isn't that nice? We'll do that in a couple days or so. Okay, and the last one, 1, negative 1, 1, negative 1. This one is the other way around.
So it's one switch.
Divergent. Next term would be positive 1, obviously. How do I get odds to give me positive 1 and evens to give me negative 1?
Negative on the outside. Put another negative.
All right. Yeah, actually, you could do negative of negative 1 at the end. That would too. The classic way to do it, here's the way to do it in college, is to make it negative 1 to the n plus 1. Doesn't that plus 1 make an even into an odd and an odd into an even? And it'll switch it. Okay? Which is actually the same thing. It's not a nice one. Okay. You can be creative. You can do negative 1 to the n plus 3. Because wouldn't that change an odd to an even and an even to an odd? Okay, so you do that. You can do n plus 1001. As long as it's an odd number, it'll change the oddness and the evenness. Okay? All right, so that is that trick right there. Very clever. Okay, and now it's time for the last section. The coup de grace. Often Miss Brown says coup de grace. And that is where we have the most advanced sequences. Challenge us, Mr. Ray, okay? This is too easy. Come on, Mr. Ray. Do something hard.
Is this like your favorite thing to do?
Oh yeah, I love this stuff. Absolutely. Actually, this is why I got my master's degree.
Really?
Yeah. Because when you get a master's in math, you have to pick like the specific subject matter. So I did like sequences, series, combinatorics, that kind of stuff, code cracking.
You're gonna do a code cracking?
Yeah,
We have a code record.
That's awesome.
was going to do code cracking.
For you to say.
My calling was to be a
Oh,
teacher.
she'll make passwords and see how long you should practice.
Okay. Pretty easy, actually. Okay.
What?
Game on.
I mean, pretty difficult altogether. Yeah, of course. Yeah.
Password.
Okay. All right. Never been on the CIA
It's on
website.
Facebook gets hacked.
Okay. Now let's see what we have here. All right. A sub 1, A sub 2, A sub 3, A sub 4. As you can tell here, we are adding 5. That's pretty easy. All right. New trick, which you may have done in Algebra 2. Arithmetic and geometry.
I hated it.
Hey, no, this is your favorite. This is your favorite subject.
This was like,
These are awesome.
well, I can work, but
That's Stephanie back there. Okay, yeah. Arithmetic comes from addition,
Notes on the-
Nice.
you gotta use the-
okay, adding, or arithmetic would go along with a what type of graph? Linear. Geometric means that you are multiplying, which means that goes along with an exponential graph. Very good. Okay, so you're looking for addition and multiplication. All right, so we are adding 5, adding 5, adding 5. Oh, that must be a what? Arithmetic. That's right. Okay, arithmetic sequence. There you go. And it's actually spelled the exact same way as arithmetic, but pronounced differently. All right, 5, 10, 20, 40. This is times 2 times 2 times 2. So this one is obviously a what? Geometric. Okay, those are pretty easy to remember. All right, next one, 8, 7, 6, 5.
Plus -1.
Okay, we are subtracting 1, subtracting 1, subtracting 1. However, well said, Mr. Steve. You are subtracting, but you're actually
Adding a negative.
adding a -1, so that is also arithmetic, definitely. All right, next one. 20, 10, 5, 5 over 2.
I wonder what that is. Multiply by one half.
Okay, divide by 2, divide by 2, divide by 2, which is the same thing as multiplying by 1/2. Mr. Wade, you didn't say anything about division up here. Well, division is actually just multiplication, isn't it? Okay, reciprocal. So that is definitely, that's right, definitely geometric. Okay, indeed. You know what? Is this converging or diverging? Half, 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 half is gonna go down to 0 and never get there, right? That is definitely diverging. You may have noticed, by the way, in the front page.
Wait, it's definitely what?
All right, let me say, take 2. I'm going to say converging, yes, it's definitely converging, and you notice on the front page, the only time you get converging is when you're using division. When you multiply, it gets bigger, when you add, it gets bigger, when you subtract, it gets smaller and goes through the floor, but when you divide, that's how you get one of these convergence sequences, only by division. Okay, so remember that. All right, okay, and finally, last but not least, we have 7, 10, 13, 16, what's that? That is plus 3, plus 3, plus 3. So that is arithmetic. All right.